get into sequences and series. So first up, this is the type of thing we're going to be looking at today. Determine the pattern, and then can you find the next term? So what do you notice about the list of numbers in the first one?
They're all numbers.
They're all squares. They're all perfect squares. So it says determine the pattern. I'm not going to write an essay. I'm just going to say perfect squares.
Not enough information went on.
And what would be your next perfect square in the list?
49.
49, because it asks you to find the next term. Well, that wasn't too stressful. Okay, what is the pattern in the next sequence? What do you notice about them? They're going up by 3. You're adding 3 every time. So I'm just going to say add 3. And clearly, super duper easy. What is your next term? 11.
You're not.
Now, as we go through the chapter, we will look at some very specific types of sequences, arithmetic, geometric. There are some formulas for them. Today, though, no formulas. We just have to be able to look at these lovely numbers and come up with the pattern, what is happening to them. We're also going to talk clearly about sequences. There's this what's called recursively defined sequence. We use previous terms to make the next term. It's very simple. We just have to look at the notation, and then we're going to talk about how you add up the terms, so on and so forth. So, sequence, of course, is an infinite list of numbers. So catch this little dot, dot, dot at the back. That's what that means. It goes on forever, obviously. And you can see how you label them. The first term we call A1, second term A2, third term A3. You always start with 1 unless once in a blue moon they'll tell you to start with 0. But if they do not give you a little note that says assume the first term is A0, you always start with 1. A1, A2, A3, so on and so forth. Nth term is just the pattern or the formula we're going to be writing that summarizes what is going on. Are you adding 3 every time? Are they perfect squares? So on and so forth. Okay, find the first 5 terms and then the 100th. Now, a lot of you can mental math it. I'm going to write it out for the first one. So again, we're going to start with 1. Then we're going to do 2, 3, 4, 5. I'm glad there's only 5. I'm running out of room. So easy enough to find the first term. You're just going to put a 1 in for n. Most of you can mental math it. 2 times 1 minus 1. What's your first term? 1. Now put 2 in. What's 2 times 2 minus 1? Put in 3. What's 2 times 3?
5.
Minus 1. What's 2 times 4 minus 1? And last but not least, what's 2 times 5 minus 1? Now, on your homework, do not need all this middle work. Obviously, I trust that you can mental math it and get me the 1, 3, 5, 7, 9. Plus, let's get serious. After I do the first few, I see the pattern. What's the pattern?
Plus 2.
So I just add 2. I don't even be like, oh, what's 5 times 2 minus 1? I just know you're adding 2 every single time. Now, they also want you to get the 100th term.
199.
So I'm glad I don't have to write out all 100. We just need the 100th. So 2 times 100 minus 1. Got it. This is majority of what you're doing today is writing out different terms, okay? And again, I'm probably going to have way more work than you on the homework. I don't expect you to do the little, mental math stuff. Just do it. Okay, let's do this one here, of course. So to get our first term, second term, third term, fourth term, fifth term. And again, a lot of mental math here. I'm going to write it out for the love of math on your notes here. We're going to put 1 in first. So what's 1 squared minus 1? First term is?
0.
What is 2 squared minus 1? What is 3 squared minus 1? Now here it's hard to see like if there's a specific adding or subtracting amount between the values, so I am going to keep doing the calculations. What's 4 squared minus 1? And your last term, what's 5 squared minus 1? And again, on your homework, you can just give me the 0, 3, 8. You can give me the final answers. Now don't forget too, Lord help us, that once the 100th term, we might need a calculator for that. Because is 100 squared a big, big number? Kind of, sort of, right? So what's 100 squared minus 1? Got it. That's a 9. That's a sloppy 9, sorry. Okay. Any questions on the first two? And like I said, this is majority what the homework is today, so that's why I said it's pretty easy. All right, you know I love some fractions, so let's just kick it up a notch, right? So same thing, we're just putting 1 in for both ends. You have ends in multiple locations, big deal. Put a 1 in on the top. Let's mental math it, 1 plus 1 on the bottom. Okay, let's put 2 in on the top, 2 plus 1 on the bottom. This isn't so bad. 3 on the top, 3 plus 1 on the bottom. Let's put 4 in. 4 on the top, 4 plus 1 on the bottom. And I like, none of those fractions can be reduced, so this isn't so bad at all. Let's put 5 in. 5 on the top, 5 plus 1, 6. And then of course it wants that 100th term. So what lovely fraction is your 100th term?
100 over 101.
Got it. This is too easy. Okay, moving on. Okay, so again, just some fractions, some more calculations, nothing crazy here. Let's see if we can kind of do some mental math. What's negative 1 to the first? And what's 2 to the first? So we're going to have negative a half. That's fine. I like it. Let's do squared now. What's negative 1 squared? 1. Positive 1. What's 2 squared? Let's throw 3 in. What is negative 1 cubed? Negative 1. Negative 1 times negative 1 times negative 1. Negative 1. And what's 2 to the third power? 8. So notice the numerators are just rotating between negative 1 and 1. It's just because of that odd even exponent. Okay, to the fourth. Negative 1 to the fourth. And 2 to the fourth. And let's do the fifth term, of course. Negative 1 to the fifth power, odd exponent, negative 1. What's 2 to the fifth? 30. All right, and then we need that lousy 100th term. Oh boy. Okay, what's negative 1 to the 100th? Or, yes, what's negative 1 to the 100th? 1. What's 2 to the 100th?
A lot.
Punch it in your calculator. It kicks it into scientific notation, right? Because is 2 to the 100th power a large number?
Yeah.
Yes. So because I don't want to put scientific notation in my fraction, I don't want like a times 10 to the whatever in my fraction, I'm just going to put 2 to the 100th. Because it's so large, okay? And I just don't want to throw scientific notation in my beautiful fraction, okay? So any questions on the front side? Piece of cake. Okay, here's where it gets a little spicy.
Oh boy.
You have to be able to look at these numbers and come up with some type of formula that generates them. So we're working backwards. I'm giving you all the answers. You're coming up with a formula. Now, my advice is this, because this is one of those things I can't just say, oh, well, if you do this and add 5 and use this formula, it'll work every time. No. They're all different. You got to be able to look at it and just figure it out, which is really, I know, super fun. So here's my advice. I try to, especially on a fraction, I first look at the top numbers separately, see if I can come up with a pattern for that, and then I find some sort of pattern on the bottom numbers. And of course, we're going to have a fraction here. Now, on this one, I think maybe the bottom numbers might be easier. 2, 4, 6, 8. They're all multiples of what? This is 2 times 1, 2 times 2, 2 times 3, 2 times 4. So my formula for that, is just going to be 2 times n. Because remember, we first put 1 in, then I put a 2 in, then I put a 3. 2 times 4 is 8. We got it. The top, I think, is a little harder to see. Yes, they're going up by 2. But don't read this. If you try to use n plus 2, you can't get the first one. Because if I put 1 in there, what's 1 plus 2? Not it. Okay, so we got to come up with something else. Another way to come up with 1, 3, 5, 7. Don't all yell at once. Mason, got a guess?
N times 2 minus 1.
So let's try it. Okay, if I put 1 in here, what's 1 times 2?
2.
Minus 1?
1.
Oh, put a 2 in there. What's 2 times 2?
4.
Minus 1. I think we're in business, right? The only thing I'm going to do, I'm just going to put the 2 first, because I'll keep the shit first. I'm going to put a 2n minus 1. But same thing. Good job, Mason. So this is like the hard part of today, because there's no magical formula. You just have to look at it and come up with them. Good stuff. Okay. Now, I'll help you with the rotating signs. I'll help you with the positive, negative switch. You just figure out what is the pattern between 2, 4, 8, 16, and 32. So obviously there's something to do with 2. So I hear multiples of 2. So if I do 2n, multiply, what's 2 times 1? 2 times 2. 2 times 3.
Oh, it's multiplying the last number by 2.
So I don't want to say multiples of 2. It does involve 2.
It's power.
Powers. What's 2 to the first? 2 squared. 2 cubed. 2 to the fourth. Okay, so it is powers of 2. I'm going to leave a little room because I'm going to help you with the rotating sign thing. So leave a little space here. We're going to put 2 to the end. Now, on purpose, this is why I made you do so many on the front side, guys. On purpose, this is why I made us do this problem, because we saw that the signs rotated when we wrote out all our 5 terms. When you do -1 to the n power, that is what will rotate your signs for you. It will alternate them from positive to negative. So I'm going to flip back to this. Let's flip back to this. So I'm just going to put that -1 to the n in front of it. Because if I put a 1 in there, negative. Squared, positive. Cubed, negative. So on and so forth.
Just write that as negative 2 again.
Well, here's the, so you want to write it how? Say it again.
Negative 2 again.
You can for this one, for sure, it's the same thing. I just, in future, if we're rotating signs on some fractions or anything weird, that does the rotating of the signs. But yeah, you can condense it to that for sure, okay? Either one, I don't care. Let's put an AN on this, I guess. Okay. So this, to me, today, this is the only tricky stuff I have for you are these, because there's no formulas, you just have to be able to look at them and do them, okay? All right. Here we go. Let's talk about this recursively defined sequence. I'm going to be honest with you. The notation looks crazy, but the math is super easy. Dom, are you awake back there? Thank you, Trenton. Focus, Dom. Okay, so some sequences, we don't have these nice, pretty easy formulas like we just saw in those first 6 problems. What a recursive sequence is, the next term is dependent on the previous terms. So we're going to use our previous answers to make the next one. Now, how you have to do that is you have to look at this crazy, crazy looking formula. So first off, write out the first 5 terms of the sequence. Well, notice they give you the first term. I'm just going to copy that down. So they're going to give you a starting term. Clearly, we got to come up with the next ones. Now, here is the tricky part. This formula looks crazy, but I promise the math is going to be easy. You have to look at these little tiny subscripts. The n and the n-1 is what I was trying to circle there, okay? So first question for you, because it might not always be n and n-1. They might use different variables. They might have different values. What you have to ask yourself is which is higher, n or n-1? N. So this is saying to get your next term, because it's higher. It's the last term plus 2, and then I have to times by 3. So this n-1, I think of that as the last term. We're all dying in here. So last term. So to get my second term, I'm going to have the 3 out there, whatever. My last term, which they gave you the 1, they gave me that because that's why they had to give me something to start with. Sorry, let me erase that parenthesis there. And then, of course, plus 2. And I'm just going to math this out. So I'm going to have 3 times 3. Okay, and then it's just this pattern to get the next term. So it's the last term. What was our last term? 9. And then, of course, plus 2. And I math this out. So I've got 3 times 11, 33. So there's no straightforward pattern of just adding, subtracting, etc. You're using the last term every time. So let me just scroll this up a little bit here. I got some room. So my 4th term, of course, the 3 times the last term, which was 33. And now, of course, plus 2. Okay, so what's 3 times, you might need your calculator for that. What's 3 times 35? 105. So still easy, but again, like I said, it's the crazy notation that's hard. Okay, so 3 times our last term, 105, and of course plus 2.
321.
So what's 3 times 107? I heard it, Ben said it, right?
321.
You got it. Okay, now here's the yuck part, and here's where I'm going to show you something maybe new on your graphing calculator. Here's the hard part. If I'm going to get the 20th term by hand, I'm going to need the 19th term to make it. Do we want to write these out to 19?
No.
No. Okay, so your calculator will do it for you. Pull up your calculator. I'm going to show you some new stuff here. Now this is easy, but I don't know how much you've used this function before, so I'm going to make a note, especially where one of the keystrokes is for you. First thing you have to do is go into mode. Clearly, we're working on sequences. So I'm going to pull this function, I'm going to put it over on sequence. I'm going to put the mode on sequence. So I'm just going to down arrow, I just got to get over to it. Polar coordinates are fun. Okay, sequence, enter. So I'm going to, and when we're done, I'm going to put it back on function. So now what happens when I get out of this and I go to y equals, check it. It is no longer y equals.
Wow. That looks cool.
Okay, so are we ready?
No.
Yes, we are.
Yes.
We are. We are. So first off, we're going to keep it, you should be defaulted to this top one already, because notice ours is, you tell her shoes, just AN, so not N, this does not say, I know I kind of wrote over N plus 1 or any of those other ones, you want to just keep it on the first one, just the N. Okay, so we need to type in the formula. So I'm going to type in the formula. The formula says 3, parenthesis. Now here is where you have to, and I always have to write myself a note because I hardly ever use this where to find it. Notice you've got, they're using for a variable these U's, and I'm going to write this down once I show you where it is. So to pull up the U for our variable, you have to hit second, it's right above 7 here, second 7. Every year I have to make myself the note where that darn U is, second 7. And then I'm going to parenthesis N minus 1. Now N is right here next to your xt theta n. When I put it to sequence mode, it takes it from x to n. So of course n minus 1.
Wait, can you go back to the end? What?
Second 7.
Second 7.
And then we were adding 2, right? The formula, yeah, plus 2.
Where's that? What?
So where's the end?
2.
It's X.
Sorry, 2.
I normally put an X in. That's good now.
Come on now.
Oh, and if you're
Okay,
you,
so have it typed in. Yes, no, yes, no.
Alright.
We have that typed in, yes?
Yeah.
Yep.
Okay, now you have to also, notice these have these are blocked. You have to fill those in. Well, they gave us the first term. Let me go down to it. The first term was 1. And my second term, I've got it covered up here, was 9. I'm going to put that 9 in. Okay, does everybody have that typed in?
And then can you just go into the table and grab it?
Because we switched our mode to sequence, so it takes it off of X and defaults to N.
Oh, this is another scientific.
Now pull up your table, and you should be able to scroll down to the 20th term. And it puts it in scientific notation, which is fine. We're going to write it down. I just want to leave this up because I see people still looking at it. So once you're done, you can just go to the table, second graph, scroll her down to 20.
Okay, here we go.
Aaron Ballard.
5,649,045,865.
So I'm going to, so I got to scroll down to 20.
Mine won't let me see mine.
I'll have to look at it. Lord help us all.
It won't help me.
So I have 4.65. What's the E mean?
Times 10.
Times 10
If you like
to
scroll
the.
over to the number, it'll show you the actual value.
So, and I don't care, like, if you do
Just
the
'cause I don't like
scientific
scientific.
version of it or you put the real number. Either. So let me give you a minute to jot that down.
Let's talk about my little.
I'll look at your calculators individually at the end.
But this is your calculator.
Which one is your own calculator? But anyhow.
Hey.
Okay, so just again, I'm going to pull up y equals to show you the screen. Now, again, there's not a lot of these on the homework, but it's important you know how to do your calculator. Otherwise, if you're doing it by hand, I have to keep this list going till I get to the 20th. Cute. I don't want to do that, okay? So again, U is second 7, you can see it right above there. N is right here on your X key. When you switch to sequence, it takes it to N for you. You just have to type it in. Now here's the thing, we're done with your calculator. You probably want it back to function mode for future classes, use, whatever. So just go back into mode, put it back on function. And now when I go back into my y equals, it's your normal.
And I assumed that it was something that you were giving me.
All right, I will help you with your calculators later if we need. Let's move it on. Okay, find the first 5 terms of the sequence defined recursively. Now again, these are easy, but you need the last term to make the next term. You have to look at these notations. So what is higher, k or k minus 1? So this is saying to get your next term, it's the previous term plus 3. Well, that's not that hard. So my previous term was 15. Mental math it. What's 15 plus 3? Okay. To get my next term, it's the previous one plus 3.
21.
To get my fourth term, it's the previous plus 3. And the last term that we need, they want 5, 27. That wasn't so bad, okay? All right, at least I hope it wasn't so bad. So one of the famous recursively defined sequences, I don't know if you've heard of this, the Fibonacci sequence. Have you heard that phrase before?
Yes, I've heard that.
Maybe.
3, 5, 8, 13, 21.
Alex is over here reading. Oh, okay. All right. So named after 13th century Italian mathematician who used it to solve, of course, about a problem with rabbits. Occurs in a lot of applications. Now, again, easy. We got to focus on the notation here, my friends. Okay. So they give you this time they're starting at 0, which fine, and they give you this first term. Fine. Okay. So just jot down the given ones clearly. Now, it's the notation, okay? So you have to look at these subscripts, which I don't want to circle them because I'm going to probably write over them. So which out of k, k minus 2, k minus 1, out of the subscripts, which is the highest? Which is the largest? Okay, so this is saying to get the next term. Focus, people, focus. It's 2 terms back plus the previous term. So k minus 2, 2 terms back plus the previous term. So it's going to be 1 plus 1, 2. I don't know why I really wrote 1 plus 1. You probably could have got that. Okay. To get the next term, it's 2 terms back, 1 plus the previous. To get the, what do we got to go, 6 of these things? To get our next one, 2 terms back. So 2 plus the last term, 3. Okay, and then to get our 5th term, 2 terms back plus the last one. What's your next term? 8. 3 plus 5, 8. Now, I know it says 6 terms.
No.
I stopped at A5. Do I have 6 terms up here?
You do.
Yes, because this time we started at what? 0. So see what I'm saying? These recursively defined sequences are easy. I mean, we can add 2 numbers together all day long. It's figuring out what that crazy looking notation is asking you to do. You have to look at the subscripts because we're going to see that coming up more and more. So we're going to practice because you can probably guess probably the only most commonly missed thing ever are these recursively defined sequences. So we're going to practice just a couple more just to practice. So write out the first 5 terms. We're starting at 10. So again, I'm looking at the subscripts, k, k minus 1. So k is, of course, more. So the next term is the last one, minus 5, and then you got to do times -2. So last term, which I started at 10. So now I'm just going to calculate that. So I really have -2 times 5. Okay, to get my 3rd term. last term minus 5, and then times -2. So calculate that for me. What's that guy? 30. Okay, to get this guy, we're going to do -2 times what? 30 minus 5. So what do you got for this guy? -50. That's a sloppy equal sign. Sorry there. I think my sweatshirt keeps hitting it. Okay, last term. -2 times our -50. There is a negative there. It got lost in the equal. Okay, final term. 110. So again, math is simple, but you have to be able to read those darn subscripts. Okay, so I mixed up the subscripts. I gave you some different ones to look at. Same thing, 5 terms. Okay, so I'm looking at my subscripts. Yes, they are different than the last ones, but we still can interpret them. Which is more, k plus 1 or k? So this is saying to do the next term, it's 1/2 of the last term. Okay, well we can do that. What's 1/2 of our last term, our starting term of 32? To get my third term, it's 1/2 of the last term. We probably can mental math it from here. What's 1/2 of 8? What's 1/2 of 4? 2. So the calculating is super simple. You just have to be able to figure out what the heck those subscripts are saying to you, okay? So questions about any of those recursive ones? Okay, last thing I have for you.
No.
What chapter is this from?
It's a good question.
I don't know.
Whichever
Is it 6?
chapter.
Is it-
Chapter 5 that we did in January.
Yeah,
That's on the final exam.
You're silly to get me a good grade on the final
Nice.
When do we
You're
do
welcome
that?
that I'm reviewing with you. You're welcome. Okay, find the exact value of the trig function. Both of those are U and V. I will draw those in U and V in a second. This is, if you remember, on your identity sheet, which you will get for the final. This is on the back side. It's on the sum and difference formula. I'm just going to give you the formula right now. So you're going to do cos U, cos V, minus sine U, sine V. This is right off the sheet that you will get. We just have to find those 4 values and plug them in. So it says they're both in quadrant 2. So I'm going to start, of course, drawing U. Here's my U triangle in quadrant 2. And they tell you the sine of U, I'm doing this guy in blue, sine of U is 5/13. So we know opposite hypotenuse is our trig ratio for sine. Now you know the missing side, it's a triple. 5, 12.
We're getting
Now due to the location, let's check. Does the 12 need a negative? Because we're on the left, we're on the negative of the x. I'm going to leave that picture there for a second because I'm going to get the V one drawn too while I'm at it. Okay, both in 2. I'm doing V in purple. What sides represent cosine? Got it. Now again, a triple, what's the missing side? 4. And if you didn't know, you would use Pythagorean theorem, but we better know that one. Does the 4 need a negative due to its location? No, because we're going. Okay, we have everything we need. We just got to fill them in. So first I need is the cos of U. So look at the blue triangle. That's my U. What's the cosine? What fraction? Got it. Then I need the cos of V, the purple. Well, cos of V, they gave that to us. Got it. And I'll multiply those in a minute. I'll get to it. Okay, sine of U. U is the blue, opposite hypotenuse. They gave that to me, 5/13 times the sine of V. What's the sine of V? 4/5, good. Okay, I heard it. Okay, let's math it out. You could use your calculator, but I think we can mental math it. We're going to have 36 over 65 minus 20 over 65 for a final answer of, got it. So no reason to get this one wrong. You get the formula sheet, you have nice triangles, there are triples with fractions, the fraction works easy, I just thought we might need a refresher on some of this chapter 5 stuff, so that's also on the notes or the packets that, because I did put some review stuff in. You're welcome.
Wait, it's chapter